Hey everyone, Wazoo here, and in this video we're going to go through the process of creating our own Minesweeper game in C using the Raylib game library. Yeah, I think it'll be great. We've done a bunch of videos in this series so far. We've done a breakout game in C using Raylib. We've done an asteroids game in C using Raylib. And now we'll be doing a Minesweeper game in C using Raylib. Before we dig into the details of what Minesweeper is, why don't we go through a quick demo of what we'll be building today. I love that banging intro music. Okay, notice how we have a main menu here of new game, options, escape to quit. Okay, so I turned it off. So if we go into the options menu, you can see that we've got a sound and music toggle, on-off toggle, using just the normal draw text functions of Raylib. And so I'm highlighting whatever state these variables are in. So whether sound is off or on, and it plays a little sound effect for that. And same with music, we can turn it on and off. Okay, I'll leave it off for now. Then if we hit enter, we can return to the main menu and then hit new game. And you can see we have a standard Minesweeper-ish looking grid. Using the left click, we can click on a tile, and so there's probably a mine right here. I'm going to right click it and drop a flag. Same thing with here. Same thing with here. And I'll try here, and hopefully this isn't a mine. All right. Okay, and then here, oh, this is tricky. Maybe there. Oh boy. Maybe one right here. One right there. Okay, so let's see. One right there. 4. Ooh. Got me. Okay. So we get a game over. We get a time played, 59 seconds. And press enter for main menu. And that is what we have in today's little project. I think this is going to be a lot of fun. I hope you're as excited as I am to go through Minesweeper. Before we dig into the game, let's dig into the actual design of the game. I'm on the Minesweeper Wikipedia page, as you can see. And I'll just quickly read through some of the rules, and it'll help us design how we approach this game. So Minesweeper is a logic puzzle video game genre, generally played on personal computers. The game features a grid of clickable tiles with hidden mines scattered throughout the board. The objective is to clear the board without detonating any mines, with help from clues about the number of neighboring mines in each field. Okay, so gameplay. So the main loop. In Minesweeper, hidden mines are scattered throughout a board, which is divided into cells. Check. Cells have multiple possible states. Okay, we've got unopened tiles. Numbered tiles can show between 1 and 8. Blank tiles, no mines are on the diagonal or adjacent to the tile. Flag tiles appear after right-clicking an unopened tile. So an unopened cell is blank and clickable, while an opened cell is exposed. Flagged cells are unopened cells marked by the player to indicate a potential mine location. A player selects a cell to open it. If a player opens a cell containing a mine, the game ends in a loss. Otherwise, the open cell displays either a number indicating the number of mines diagonally and/or adjacent to it, or a blank tile. And all adjacent cells will automatically be opened. This may cause a chain reaction. Any blank tiles opened by other blank tiles open the surrounding tiles too. Players can also flag a cell visualized by a flag being put on a tile to denote that they believe a mine to be in that place. Flagged cells are still considered unopened and may be unflagged. In some versions of the game, when the number of adjacent mines is equal to the number of adjacent flagged cells, All adjacent non-flagged unopened cells can be opened by both left and right clicking. A process known as courting. Okay, we won't be worrying about that one. Okay, objective and strategy. A game of Minesweeper begins when the player first selects a cell on the board. During the game, the player uses information given from the open cells to deduce further cells that are safe to open, iteratively gaining more information to solve the board. The player is also given the number of remaining mines on the board, known as the mine count, which is calculated as the total number of mines subtracted by the number of flagged cells. Thus, the mine count can be negative if too many flags have been placed. To win a game of Minesweeper, all non-mine cells must be opened without opening a mine. Okay, that makes sense. There is no score, however, there is a timer recording the time to finish the game. Check. Difficulty can be increased by adding mines or starting with a larger grid. Beginner is usually on an 8x8 or 9x9 board containing 10 mines. Intermediate is usually on a 16x16 board with 40 mines. And expert is usually on a 30x16 board with 99 mines. However, there's usually an option to customize board size and count. Okay, I'll leave that as an exercise to you, dear reader. We won't be doing that. At least I won't be doing that in this demo. Okay, so I think we got a gist of the rules here. We'll be following most of them. We won't be implementing every single variant of the official Minesweeper rules, but just enough to kind of get the idea of how this game works. We've got Visual Studio 2022 opened up. Let's go ahead and create a new project. Click. And let's select Console App, which, by the way, we're not doing anything new that we haven't done in previous projects. So feel free to skip ahead. Use the timestamps down below. Clone this project from GitHub. Skip ahead to where you want to learn about, and we will keep going. Hit next. Okay, for our project name, I'll just call it Raylib Minesweeper. And I'll choose my desktop. And I will hit create. Okay, by default, the Visual Studio will create a file called raylib-minesweeper.cpp here on the right-hand side. Let's go ahead and just rename that file to main.c. There. That'll kick in the C support for Visual Studio. So let's go ahead and remove. We'll create an empty function. We'll stub this out with the same similar setup that we've done in the previous videos. So again, feel free to skip ahead if you recall. Initialized the Raylib framework, created a window, set everything up, and then shut everything down. Okay, so we will be including raylib.h and raymath.h. And then we will define a screen width of 600 and a screen height of 600. And then in our main function we will call init window screen. Oh, the IntelliSense. It's so aggressive. Screen width, screen height. Sorry, everyone. And then let's give it a window name. Let's just call it. I called it Raylib Minesweeper. That's nice and descriptive. Okay, and we're going to set our target FPS to 60 as we've done before, and we are going to be calling our game startup function that we'll make, similar to the other videos. Okay, and then we'll go into our main loop of the game. While not window should close, let's call GameUpdate, which again we'll create in just a few seconds. Then we will call begin drawing from Raylib. We will clear the background to dark blue, which almost looks like cornflower blue, at least to my old eyes. Then we will call our GameRender function that we'll create momentarily, and then end drawing. Okay, once we're done and we exit that while loop, Let's call game shutdown. And then finally close window from Raylib. And then return 0 because we're in a main function that has to return an int. Okay, so that's pretty, we've covered all these before, so I will just create the main. Okay, so we have got our main function stubbed out that we've done previously in other videos, our game reset function, our game shutdown, game render, game update, and game startup. And just as a quick test, we can run this right now, just to verify that everything builds and launches successfully. And there we go. We've got a blue window. We just need to hit escape as per usual to kill it. And let's get back to work. Okay, so our startup function, our game startup anyway, is going to go through the same process of calling init audio device. And our game shutdown will make sure to close that audio device. Now we need to, let's begin by drawing our grid. So the size I came up with was 12 tiles by 12 tiles, which is how I came up with 600 by 600. So let's define the number of columns to 12 and define the number of rows to 12. So feel free to experiment with this as you play with this code, and then you'll be able to see how many tiles you can create and what kind of sizes you'll end up with. And so once we've defined the number of columns and rows, we can create a tile width constant, which is our screen width divided by the number of columns. And then our tile underscore height will be screen height divided by the number of rows. So this calculation will give us the width and height of each tile. And in the previous two videos, we created a structure called an entity, which is what we used to render things like asteroids or bricks for the breakout game. But in this one, I'm just going to call them a tile. So let's go ahead and use a typedef struct, and this will be a tile. Whoops. Okay, and we'll have some properties here. We'll have a int x and int y, which will be the row and column index. We'll have a Boolean to track if this tile is a mine. We will have a Boolean if this tile is revealed. And we'll have another Boolean if this tile is flagged. And then we'll have in each tile will also contain a number of the nearby mine count. And then let's go ahead and declare a grid. So stile grid number of columns by number of rows. Easy peasy. Okay, so let's first work on rendering that grid. So let's create a function called, let me see. Okay, let's create a function here called render tiles. Void render tiles. We'll declare the function up here, and then let's go ahead and create it. Void render tiles. And we're basically just going to do two for loops, which will then call another function that we'll have to create called render tile. So here, for int I equals 0, I is less than the number of columns, and then we increment I, and then another inner for loop for int j equals 0, j is less than the number of rows, and then j++. And then for each of these tiles, we'll just call render tile, and we'll pass in the grid, column, and row index. Okay, so then let's create a function declaration for render tile. It takes in an stile as the parameter. And so what do we do in render tile? Okay, so this one will be constantly updating here, but for right now, we are just going to draw the tile. We're just going to be drawing the rectangular outline of the tile. So draw rectangle lines, and the X component times the tile width, and the Y component times the tile underscore height variable that we declared. The width will be the tile width, and the height will be the tile height. And our color tint will be white. Okay, so again, we're calling draw rectangle lines, passing in the X component times the tile width, and the Y component times the tile height. And tile width and tile height are the two parameters of our height, width and height, and then the color tint is white. So in GameRender, let's just call for the moment render tiles. And then this should loop through and draw all of our tiles. Before we do that, we have to create them. Okay, so in our game reset function, let's create a function here called reset tiles. And this will just initialize all of our tiles. Initialize our grid. Okay, so let's put this up here, void reset tiles. Okay, let's go ahead and declare it. Okay, so again, we need those two for loops. So for int I equals 0, I is less than the declared number of columns, I plus plus. For int j equals 0, j is less than the number of rows, j plus plus. And then within that, we will create a new, that should be rows, we'll create a new tile. So in grid I, j equals s tile, and then we can declare it like this. We can initialize it like this. So the X component, we can equal it to the I, and the Y component, we can equal to the J value. Our isMine is going to be false. Is revealed, so it's hidden by default, will be equal to false. Is flagged will be equal to false. And the nearby mine count will be equal to -1. Okay, so reset tiles gets called. Okay, so then in the game startup, let's just quickly call, we'll update this later, but for now we will call game startup or game reset from game startup, as we've done in previous videos. So let's go ahead and hit play on the debugger, and we should get lines, which we do. All right. So we got the white lines. We've got our 12 by 12 grid. Perfect. Okay, so now let's come up with placing the mines somewhere in that grid. So near this declaration at the top for our grid variable of stile, let's create two new variables here called int RevealTilesCount. Another one called mines present count. Okay, so back in our reset tiles, right there in our reset tiles function, after these two for loops, let's generate some positions for the mines. Okay, so mines present count equals to the rows times the columns times 0.1 float. Int mines to place will be equal to the mines present count. Okay, so then let's create a small while loop here. So while mines to place is bigger than 0. Okay, so let's randomize the row and column value of where we're going to drop the mine. So int column or int call equals get random value, which is a function of Raylib, between 0 and calls. And then int row equals get random value between 0 and rows. Okay, so then if the tile in this position of column and row is not a mine, then let's set a mine there. So grid column row is mine equal true. And then let's decrement the mines to place counter by 1. And then while we're in this, we are going to, okay, so we've dropped mines throughout the grid. And now what we're going to do is go into our render tile function. Render tile. Okay, so now what we're going to do is if the tile is a mine, then we're going to draw the inside of the tile in red. Okay, so we're going to use draw rectangle here. And from the IntelliSense, we can see that we pass in an X and Y position, a width and a height, and a color. Very similar to the draw rectangle lines. So we are going to be dropping in the X component of the tile times the width of the tile. Similarly, passing in the Y component of the tile times the height, and then the width and the height again, and then we'll just color it red. And let's see how this looks. So we should then be seeing all of the mines that are in our grid. Okay, so here's the mines. That's pretty cool. So you can come up with any different algorithm you want as to randomly calculating how many mines you want to create in the grid. So maybe do something like, depending on the width and the number of columns and rows, is your factor in determining how many mines you're going to have. So you could create like a neat hash table with different values depending on what you select. But at any rate, so that looks good. Okay, so now what we're going to do is we're going to calculate the number of mines that are near an empty tile. So remember in the rules that the game will give you a hint if the current mine is empty but has a mine nearby. So again, back in our reset tiles function, after we place all the mines, let's create another double for loop. So for int I equals 0, I less than calls, I plus plus. For int j equals 0, j is less than rows, j plus plus. So if the current tile is not a mine, so if not grid I j is mine, then what we're going to do is grid I j nearby mine count equals count nearby mines I and then j. So we're going to need to create a new function called count nearby mines, which take in the column and row index. So let's go ahead and up here create a int count nearby mines taking in two ints. Okay, so int count nearby mines, int column, and int row. Okay, so we're going to have a count variable and we'll just set it to 0. And then what we're going to do is we are going to be creating, basically we're going to be creating offsets. So what we want to do is we want to take the current column and row position of each tile, which we know doesn't have a mine, and we want to look in the adjacent tiles to that tile. So up and down, left and right, and the two diagonals, and then determine if there's a mine there, and then that's how we will calculate the count. So for int column offset equals -1, so we'll start at 1 minus, call offset is less than equal to 1, and then finally call offset plus plus. And we'll do the same thing with a row. So for int row offset equals -1, row offset is less than equal to 1, row offset plus plus. If the column offset equals 0 and the row offset equals 0, then keep going. We don't want to do anything with it. And if the grid of the given column plus call offset and the given row plus the row offset is a mine, so basically keep looking in the square, in the tiles around the current tile, then we increment the count. And then finally, at the end of the function, we return the count. Okay, so let's try that out. And in the render tile, let's draw the number. Okay, so render tile. Whoops, it was right here. Okay, so is render tile. So if it's not a mine, let's do an else. And then if tile nearby mine count is greater than 0, let's call DrawText. And then we'll call text format, and we'll be taking the nearby mine count. And then we'll be positioning it at tile.x times tile width plus, let's see, 13. And then tile.y times tile height plus 4. And let's see, so the height will be, or that's the width, and then the height will be tile height -8. And then finally, we will color them dark gray. Oh, that IntelliSense. I hope it's not annoying you as much as it's annoying me. Okay, so basically to recap, so if our tile is not a mine, and if our nearby mine count is larger than 0, then call DrawText, use the text format function to grab the nearby mine count integer of the tile, convert it to a string, and then draw that string at the XY tile position given the heights. And then gray is spelled with an A in Raylib. Okay, so let's go ahead and run this. Okay, that's not bad. So we've got we can see the numbers here, and it will, the colors, the coloring will look a little better once we go through and update more of this. So right here, we've got a one mine in between all the ones here, which makes sense. We've got a 3 calculated here. So let's quit that. Okay, so the other variation we're going to do is in the render tile function, right before drawing the counter, so drawing the nearby mine count, we're going to call draw rectangle again. And similar to this, drawing the color red if it was a mine, we're basically just going to color the whole tile light gray. And so then this gives us a look like this, which is what we had in the demo. So this signals that we've revealed the tile. Remember that when it's not been yet revealed, the tile color is that blue, which is what we're going to do right now. So all that looks good. We've got the board generating successfully, the numbers looking good. So all we're going to do is we're going to surround this whole block in render tile with if tile is revealed. Okay, so we're going to surround that whole thing. well, everything except for the drawing the rectangle lines. We need to keep that where it is. So everything else we just want to surround with if is tile is revealed. And so now let's go through the process of revealing a tile. In previous demos, in the GameUpdate function, we were looking for keyboard presses and then triggering appropriate behavior depending on the keys inputted. But this time we're going to be looking at the mouse click, which is something different here. So in the GameUpdate, okay, here we go. So in the GameUpdate function, let's use a function called isMouseButtonPressed, and then it's a function in Raylib, and then it needs to we need to pass in a parameter of which mouse button we're looking for. So isMouseButtonPressed, and then we're looking for the left mouse button. So mouse_button_left. Okay, perfect. So we'll be able to grab the vector2 position of that. So mouse position equals get mouse position. So we want to get that mouse position, and then what we want to do is we want to be able to detect which tile we're actually clicking on. So let's grab the column, so cast it to an int of our mouse position .x divided by the tile width number, and then the row will be calculated by taking the y position of the mouse, so mousepos.y, dividing it by tile_height. And then let's pass it into a function to detect if we've got a valid tile index, which we haven't created yet. So we'll call this one, or I called this one, is tile index valid. And it will take in our column and row value, and it will return a Boolean. And so assuming that it is, we will then reveal the tile at column and row. Okay, so we have to write two functions here, is tile index valid and reveal tile. So first let's update our function declarations up here. So is tile index valid returns a Boolean. Okay, these are ints. And then we had reveal tile. So void reveal tile, and it takes in two integers representing our column and row. Okay, so let's stub these out right now. So bool is tile index valid, int col int row, and then void reveal tile int col int row. Okay, so is tile index valid? Okay, so all we want to do basically is bounds check the column and row and make sure it falls within our grid space. So let's return col is bigger or equal to 0, and col is less than the number of columns, sorry, and row is bigger than equal to 0, and row is less than the number of rows. That's it. So assuming that returns true, then we go into reveal tile. Okay, so let's do a sanity check. So if our grid is already one that we've revealed or we've put a flag on, then let's just get out of here. So if grid column and row is flagged, or grid column row is, if it's already revealed, then let's just get out of here. Let's return. Then, assuming we continue, let's set the property is revealed now to true of grid, column, and row. And so we have a to-do here where if the current tile at grid, col, and row is a mine, then our game is over. Okay, so if grid, col, row is mine, then our game is over. And so we'll have to handle it in some way. Okay, so let's run this and see if we can at least handle the left click. We've got a grid in front of us. When we click on it, everything is revealed and it's revealing numbers. And there's a mine. So everything looks good. If we click outside, nothing will happen, of course. But we've got that bounds check in place. Okay, everything looks good. And if we double click, if we keep left clicking on a tile, it just stays the same. It doesn't change. Same thing with a mine or any of the numbers. So in the assets folder of this project, I've got a bunch of images and sound effects. So please copy them right from GitHub. Just pull it down and then you can drop it into your own project. And we will continue. So now let's go through the process of dropping a flag. So when we hit the right mouse button, then the idea is that we drop a flag on that tile. So I have an image for a flag. So what I'm going to do is now go through our favorite process of loading an image and creating a texture. Okay, so right underneath are these variables that we've already declared up here. So what we're going to do is, similarly to the other videos, we're going to define a maximum textures count. And in this case, it's just going to be 1. We're going to create a type def enum of texture flag. And we're going to give it the name texture asset. Okay, and then we're going to declare an array of texture 2D called textures, and we'll declare the array the size of max textures. We've done all this before. Easy peasy. Okay, so during game startup, after we initialize the audio device, let's go ahead and load up that image. So image1 equals load image. And I'm just calling it's in assets folder. I just call it flag.png. And then, as we've done before, textures, and then texture underscore flag equals load texture from image1. And then we unload the image. Okay, easy peasy. We've done all this before. And then finally, in our game shutdown, okay, before we close the audio device, let's just go through and clean up all of the texture images that we've loaded, which in this case is going to be 1. So we've got a for loop for I is 0 and then less than max textures. We just call unload texture on each texture that's in that array. No problem. Okay, back in our render tile function. So if our tile is revealed, then we've already got this other code. So else, let's create an else here. Else if tile is flagged, which we'll handle shortly with the mouse. So if our tile is flagged, then what we want to do is draw the flag. When we're using DrawTexturePro, which what we'll be using, we need to define a source and then a destination to draw to. Our source is going to be 0, 0, and then the full width and height of the texture flag image, or texture, sorry. That'll be the source, okay, which we've done before in our other projects. And then our destination is going to be drawing it within the tile that we've clicked on. So we calculate that by taking the X component times the tile width, and then the Y component times the tile height, and that is our X and Y. And then our width and height are just the width and height of the tile, those two constants that we have. And then our origin is going to be, remember that our DrawTexturePro takes in an origin, and it's just going to be 0, 0. Let's use DrawTexturePro. We're passing in the texture flag texture, the source, the destination rectangles, the origin, and the 0 rotation. We're not rotating anything. And then the color tint is white in this case. So that's how we draw it. Now let's take a look at handling the input in order to draw that flag. So let's go back down to the game update. Here we go, game update. Okay, so then else if is mouse button pressed, and then we want the mouse button right, the right mouse button. Okay, so it's kind of the same thing. We want to grab, actually everything is the same. We want to take the mouse position using get mouse position. We want to calculate the column and the row. Okay, let's just drop that in here. And then we want to use if is tile index valid again. We want to double check the bounds, but instead of calling reveal tile, we want to put flag tile. So we're going to create a new function that will take in the column and row index and then drop a flag in that index. Okay, so let's declare the function up here again. Void flag tile int. And so we can just put it right above reveal tile. So void flag tile int column and int row. And then so if the current tile is already flagged, then we're going to return. So if grid call row dot is flagged, if that's true, return. Otherwise, we want to toggle the flags. So how we accomplish that is we set the value of is flagged to be the negated value of that same variable. So if it's true, it'll be false. If it's false, it's true. And eventually we'll place a sound here when we drop a flag. But let's now run this and see what happens. Okay, our left mouse button does its thing. And then right mouse button draws a flag. Okay, so the other piece of logic that we have to work out is that if we click on a tile and it's empty, then we want to spread out, we want to empty everything else that's kind of around. So back in our reveal tile, let's go there right now. Okay, so we have our if there. So if our tile is already flagged and revealed, then return. We set, remember we were declaring if there's a mine in that tile, then it's game over. Okay, so here's where we'll create an else. So else, so if the grid, basically if the tile at the current position, at the current call row position nearby mine count equals 0, then we want to reveal tiles from column and row. So basically start that algorithm that spreads out where we are. Otherwise, let's tiles count, we increment that to keep track of how many tiles we're revealing. And then so if the tiles, if revealed tiles count is bigger than the rows times the number of columns minus mine's present count, then we win. To do, we win. Okay, so to do, game is over. So we lose if the tile is a mine. Otherwise, we spread things around, or we try to reveal all the tiles from the nearby tile. And if there's no more to reveal, and it's larger than the calculation of rows, let's put these in brackets so that it might be easier to grok. The rows times columns minus mine's present count, then we've won. Okay, so let's create this function, RevealTilesFrom. So basically it's a void RevealTilesFrom int. Okay, void RevealTilesFrom int column and int row. So we're kind of going to do a similar process of what we did when we calculated the nearby mine count, where we have a column and row offset. So I cut and pasted those two for loops in here. So if remembering again, so if we move from the -1 column offset up to the +1, and same thing with row offset up to the positive row offset. Okay, so again, if the column offset equals 0 and the row offset equals 0, then continue, go to the next one. If not is tile index valid, so if the index isn't valid, so column plus col offset and row plus row offset. So if we're getting into dangerous territory, then just continue in the loop. So this is to handle the edge case of being near the edge of the grid. Otherwise, let's call RevealTile and then column plus col offset and row plus row offset. Give it a shot, see how it works. Okay, that worked pretty good right on the first click. We can drop a flag. Okay, we got a mine there. That's lots of mines, holy smokes. Okay, let's go ahead and play with our state machine. So we haven't yet worked with game states. Usually video games is usually only in one state at a time. So for example, you're in a main menu, or sorry, let's back that up. Before you get to the main menu, you usually see some kind of logo come up, like the company logo, right? And then you get to a main menu screen. And then you're usually able to choose from a bunch of options, like let's say, new game, load a save game, see the credits, see the options, or exit. And then so that will be one state. And then if you click into a different menu, like let's say the options menu, since that's what we're using here, then you move into another state where you're in a options menu state. And then you maybe return back to the main menu. And then finally you hit new game and you jump right into the game. And then there'll be another state where you might win or you might lose. So those are two additional states. So to help, maybe if you haven't encountered using states yet before, maybe think of a traffic light. That's usually the most easiest analogy. So you've got a state of red where no one can move, a state of yellow where the light is about to turn red, and then a state of green where you can go, cars can drive through. Now, of course, there's edge cases where, like, if the power goes out, then usually by default, the traffic light flashes red. But let's say, for example, that there's nothing wrong with the power and we just have red, yellow, and green. So those are the only three states that the light can be in. It can't be both red and green or both yellow and green or green and red, etc. And so this is kind of what we want to create within our game. We want to create a way where we have different options sometimes different inputs that we're accepting from the player at different states of the game. So for example, for main menu, our left and right mouse buttons, we don't want anything to happen when we click left or right mouse buttons. We only want to be able to select the main menu options for our game. Similarly, when we're in playing the game, and then we try and press some of those key presses that should only be applicable to the main menu, we don't want the logic taking over of as if we hit those keys from the main menu, right? Like since we're in a different state, then we should ignore anything that's not valid in that state. Okay, so underneath our textures here, let's create another enum. So type def enum, and I'll just call this state main menu. So that'll be the first state that we can be in. And then we've got a state options menu. As you saw from our demo, we can be in a playing state, or we can be in a state lose or state win. And then we'll just call this game states. And then we'll have a global variable here called game_states of game state. So basically what I usually like to do is in the GameUpdate and GameRender functions, I create a switch statement that will then decide which state we're in and update things accordingly. Okay, but first let's go to our GameRender function. We want to create a switch statement here. So switch game state. So case main state main menu case. Okay, so we have the different states here. So if we've got different code that we want to run depending on which state we're in. So we've got the state main menu again, the state options menu, state playing, state lose, and state win. So if we are in playing, we want to render our tiles. Same thing with the lose state and win state. We want to be able to show the board behind those game over screens. Okay, and then what we're going to do is basically just copy this whole switch statement and drop it into GameUpdate as well. So let's drop this in at the top here, and then of course take out the render tiles function calls since we're in the GameUpdate section. Now we only want to handle these mouse button clicks if we're in the game playing state. So let's cut and paste that back into state_playing. Okay, so in game startup, let's take out this game reset call from game startup. And right at the end here, let's just set our game state to be the main menu. Let's see, what are we going to do? So in the main menu, so in our update, we're in the main menu. Okay, I basically created two options. So we can either hit N to start a new game, or we can hit O to go into the options menu. So let's first go into the game, the new game. Okay, so in the switch statement for state_main menu, if our N key is pressed, then just call game reset. And then within game reset, after we reset the tiles, let's set the game state to be playing. And the revealed tiles count, we're going to have to set that to 0. So let's go to our lose condition. Okay, here we go. So let's go to this to-do that we dropped here. So when the game is over, when we reveal a mine, so let's take out that to-do. We will change the game state to be equal to state lose. Okay, and then we're going to capture the time. So time game ended equals float get time. Okay, and then if we win, remember there's that win condition. So let's take out that to do. And so let's set the game state to be state_win. and then time game ended to be the current get time. Okay, so we've got the values of our game times, and we've got different states. We've got a win state and a lose state. So let's go ahead and quickly just draw some text when we get to those different states. Okay, before we do that, what we're going to do first, in our GameRender code, now we're going to render our main menu. Okay, so in our GameRender function, we're at our main menu, and so all we're going to do is we're going to draw a rectangle around the screen and fill it with dark blue. So draw a rectangle starting from 0, 0, going to screen width and screen height, and then using the color dark blue. And then we are going to draw the text Minesweeper. So drawing Minesweeper at X and Y of 2020, and then the font size of 40, and then the color text is white. And then we're going to draw a few more lines, basically our menu options, which we saw in the demo. So we're going to call DrawText again with new game at X of 120, Y of 220, font size of 20, and then the color white. And then similarly, we're going to draw the text for options at 120, 250, and then escape to quit at 120, 280, and then some other text for copyright 120 by 500. You could also, like, this is basically the credits, so you can put in, programmed by and your name, whatever, blah, blah, blah. Okay, so let's handle that. And then in the GameUpdate function, let's see, can we work backwards? Oh, cool, we can. In the GameUpdate function, okay, we've hit N and we reset the game. We call game reset, which will then put us into the playing. And then finally in the lose, is this the update? This is the update. Basically in the win and lose states, the enter key will take us back to the main menu. That's all I've put in for this demo. So in our state lose, put in a function call if is key pressed, key enter, then set the game state to state main menu, and the same thing for the win. So winning or losing, we take the same enter key. Okay, and then down in the render function, let's go ahead and update some text. Okay, so let's go back up to GameUpdate and go down into GameRender. Okay, so we're in our playing state, we're rendering our tiles. Okay, so we lose and we win. So in the lose state, what we want to do is we want to basically create a overlay. Remember that white overlay. So we're going to call draw a rectangle again. We're going to fill the whole screen with white, but then we're going to call a special function called fade, which will basically create that overlay of see-through. So we can see the grid behind the white, but it's not so transparent that we don't see the white, basically. And then what I want to do is draw the text game over. So I've created a string for game over, and we want to calculate where to drop that. We want to put that right in the middle of the screen. So we take the width divided by 2, and then we can use another Raylib function called measure text, and then the string and then font size that we're measuring, and then basically position it at the middle of the screen at the middle of the height in 60 font size, and then dark gray. And then similarly, we want to draw the press enter to return to the main menu screen. So let's go and create these two variables. So let's go back to the top again. Okay, and let's create a const char string of label game win. You win. And then another one, const char string of label game lose. We'll just say game over. You can also say you lose, whatever. or kaboom, const char label enter, and that'll just be the text. Press enter for main menu. Okay, so let's go back to the GameRender function. Okay, so we've rendered the text for losing, and now let's render everything for winning. So we've drawn our lose and press enter screens, and now let's draw the time that we played, like how long it took for the player to lose the game. So we're going to create a calculation here. We're going to call it seconds, and we're going to take the difference between our time the game ended minus the time the game started, and taking a mod of 60. So basically it's not dividing by 60, but we're modding it by 60 in order to count how many seconds total that we've got to work with. So up here, let's create a variable, an integer called seconds, and just set it to 0. And then we have a drawText function, which will then use the text format function that we've used before and create a string called time played, and then drop in the calculated number of seconds. And then we're drawing it at X and Y of 20 and 40, of size 34, and the dark gray text. So we basically want to do the same thing to the win side. So let's just take this whole thing, because it's pretty much the whole thing. We'll cut it from there and we'll paste it into the state win. But instead of drawing the label game lose, we'll draw the label game win. And we'll update this right here as well, label game win. And the rest of it should be the same. Okay, so we've got our main menu screen here, the state for main menu, which looks good. We've got our new game, options and escape. So if we hit escape, it should still quit. Let's try running it again. And if we hit N, we should go back into our grid. Our left and right mouse button click works. And when we hit a mine, boom, game over. So we've got a time played of 6 seconds and a enter for main menu, which then works. When we hit enter, we go to main menu. Our left and right mouse buttons don't do anything here. Okay, so let's go through and add some sound effects. And this is basically, we're in bonus territory now. That's the main gameplay loop. Or let's see, let's combine it with our textures. So after the textures, let's create an enum for the sound effects. I've got 3 sound effects. So we were declaring a variable max sounds of 3, and then we've got sound 1, 2, 3. I would recommend changing those to maybe something more meaningful, but for now I just used sound 1, 2, and 3. Of course, I'm going to forget what they are as we go through this demo again. And then we've got an array of size max sounds, and then we're going to do the same thing with our music. We've only got one music track, so I've set a max music variable to 1, and then we only have one music underscore 1 in the enum, and then of course we declare the array max music. Let's go ahead and load up everything. Okay, so in our game startup, let's control click on the function which takes us there, which I should have mentioned long before now. So after we load the image, let's load the sounds and the music. And again, we've done all this in our previous games. So in the project, I've got a couple of sound effects and a music track. So for sound 1, 2, and 3, I've got like a click sound, an explosion sound when the mine goes off, and then a pick up coin, which is basically what I'm using for selecting menu options, things like that. And then I've got a music track. So we use load music stream. And then I've got an MP3 that I've got with the project. Okay, so we've got all those loaded, and now let's go to the unload in the game shutdown. So after we unload the textures, let's unload the sounds. So again, nothing new here. We've got another for loop of going through all the sounds in the array and calling unload sounds. And then we want to stop the music stream, which is our background music, and then call unload music stream and our music track that we want to unload. So in our startup, I forgot to, right after we load the music, let's go ahead and play it. So play the music stream, and then music 1. Now what we also have to do is within the update, the game update, let's go in there. So before we go into our switch statement, we also have to call update on the music stream. So update music stream and then music 1. So that should be our sounds and music playing, or well, at least our music playing. So now let's play a sound effect. So when we hit the N key, let's call play. Actually, you know what? I'm going to create a function for it. So game play sound, and we're going to call it sound 2. That's our click sound. Or no, it's the explosion sound, sorry. So we're going to play the same sound when we go back to the main menu from the lose state or the win state. Okay, so now we need to create this method called gamePlaySound. So let's go back up to the top into our functions here, and let's just call this here. You know what? We'll stick it with our game functions. gamePlaySound int sound, and then let's define it right here. So void gamePlaySound int sound. So what we want to do here is just call play sound. Given the integer, we use that to play that index into play sound. And we'll see shortly why we're doing it this way within a function. Okay, so if the other place we want to play a sound effect is if our game is over. So if we reveal a mine, so right here, if we reveal a mine and we set our state to lose, game play sound 2. And then we want to play that coin sound when we drop a flag. That's where I also put it. So let's look for flag tile. Okay, so in our flag tile function, so after we drop the flag, let's play a sound effect. Games play sound 3. So again, you could rename it to be something a whole lot better than just sound 1, 2, and 3. We're playing another sound, the click sound, when we reveal a tile. So in the mouse button, okay, so is mouse button pressed? So let's see, we reveal if the index at this tile is good, we reveal the tile and then we play the sound. So game play sound and then sound 1. Okay, let's try this out. Okay, so we got our music coming through okay. Okay, we got the sound effect when we hit a menu key. We got the sound effect when we drop a flag and when we hit an empty tile. And then we got a game over sound effect. Okay, everything looks good there. So now let's quickly code up the option screen. And it will be very similar to the main menu. So okay, so here we go. So we are in the update loop. So if we detect if the O key is pressed to go into the options, we set the game state to state options menu, and we play that sound 2. Okay, and then in the options menu, we've got a few functions here. So we've got enter. I used enter to return to the main menu just because normally you would use escape, but in our case, escape would just exit the whole game. So if is key pressed, key enter, then set our state back to the main menu, and then play that same sound too. Okay, now otherwise we can toggle the music and toggle the sound. Let's handle the case of toggling the sound first. So if key is pressed, then we'll have a global variable called isSoundEnabled, and we'll just toggle it on or off. And then we'll play the sound 1, each time we toggle it on and off. And we're going to do the same thing with music, except with the added wrinkle. So if we press the M key, it will then toggle the isMusicEnabled Boolean and then play that sound effect. Now, if the music toggles from off to on, then what we have to do, or what we should do anyway, is call stop the music stream of that background music and then start it up again, so play it. Otherwise, we want to just stop the music stream. So this basically resets it. So if we go from off to on, we reset the music state. Okay, so now let's create these two global variables. So isMusicEnabled and isSoundEnabled. Okay, so let's just put them right here. Boolean isSoundEnabled equals true. So by default it'll be true, and bool isMusicEnabled will be equal to true. Whoops. So in our gameplay sound function, which we just created, we can add in the if condition. So if isSoundEnabled equal to true, then play the sound. Let's go ahead and try this out. Oh, we didn't render the options, but we rendered the keys at any rate. So let's take in M. So M toggles the music, and S will toggle the sound. Okay, so let's draw the text for that. Sorry about that, I forgot about that. So in our GameRender, so let's go down into the options menu. Look at all that, it's empty here. Okay, and I'm just going to cut and paste what I came up with. It'll be easier to walk through it. Okay, so I've got another similar drawRectangle call which fills the screen with that dark blue. And then at the top of the screen at X and Y of 2020 in 40-point font size, I'm just writing the text Minesweeper options. Okay, and then further down I've got a draw text for sound at 120 to 20, and then basically I've got a way of representing if the sound is enabled or not. So I use the yellow highlighting on or off depending on the state of isSoundEnabled. So if the value of isSoundEnabled is true, then that means on should be in yellow, and then I draw the rest of the text, the slash and then the off. Similarly, if sound is off, then I draw on in white and off in yellow. And then we do the exact same, we follow the exact same process for music, toggling the music on and off with M. Okay, let's go ahead and play that. So we're going to options. Okay, everything is on. Let's turn off the music. And now we can toggle the sound on and off. So let's turn the sound off. Keep that off there, and then go back to the main menu, and then new game, and notice how everything is quiet. Game over, boom. Okay, and then let's go back into options, toggle the sound to on, press enter, new game, boom, game over. We only lasted 1 second on that one. How about that? New record. Okay, and I think that is it. I can't believe it. I think we got through this whole game. Woo! Okay, party time. Well, that was it for this video. I had a really great time. We went through Minesweeper, putting this whole game together from scratch, from start to finish, using the Raylib library in C, and having a lot of fun in the process. There's a lot of sections here that you can play with on your own, test out different ideas, different theories. You can create different tile sizes, which I urge you to do. It'll be a fun little experiment. You can drop in your own sound effects, your own tile. You can even use tile images instead of just drawing red or not red, instead of just drawing, well, red for the mine and blue or the gray color. But that was it for this video. I hope you liked it a lot. Give the video a like, subscribe to the channel for notifications on other videos like this, and we will see you in the next one, folks. Peace.